Haloalkanes. Class of haloalkanes. It depends on the classification of carbon that bonded to the halogen. This is primary haloalkane because the halogen is bonded to the carbon, which is primary carbon. This compound is secondary haloalkane because the halogen attached to the carbon that is secondary carbon. And this compound is tertiary haloalkane. Nomenclature of haloalkanes. First, give the lowest number to the substituent. If the numbers are the same from both sides, follow alphabetical order. 2-bromo-5-methyl-hexane. The parent name is hexane, the longest carbon chain which has halogen bonded to it because it's haloalkane. So this is the longest carbon chain which has halogen. So number 1 will be numbered for this carbon because the lowest number must be given to the substituent 1, 2. And if you start counting from the left, it's 1, 2. Same. So if the numbers are the same from both sides, follow alphabetical order. This substituent is bromo and this methyl. So B before M, because if you start counting from the left, the methyl will get number 2 and bromine will get number 5. If you start counting from the right, the bromine will get number 2 and the methyl will get number 5. So follow alphabetical order because the numbers are the same from both sides. So the name will be 2-bromo-5-methyl-hexane. For the second compound, if you start counting from the left, it will be 2 and 4. If you start counting from the right, it will be 3 and 5. So 2, 4 is lower than 3, 5. So the name will be 4-bromo. If you write the name, you must follow alphabetical order according to the number you've give to the carbon. So 4-bromo, 4-chloro, 2,2-dimethylhexane. For cyclic haloalkanes, give the lowest number to the substituent. If the numbers are the same for clockwise and anti-clockwise, follow alphabetical order. So it's very much likely the same for the rules as in straight chain carbon haloalkanes. For this compound, the parent is cyclohexane because it contains 6 carbon in total in cyclic, and it has 3 substituents, 1, 2, 3. So you must have 3 numbers in naming cyclic haloalkane. So give lowest number to the substituent. If you number fluorine number 1, the methyl will be 4 and 4. So if you give the methyl number 1, the methyl will get 1, 1 and fluorine will get 4. So 1, 1, 4 is lower than 1, 4, 4. So the name is 4-fluoro-1,1-dimethyl-cyclohexane. Remember, when you write the name, you must follow alphabetical order. So F before M. So that's why you put fluoro first before methyl, according to the number given. Iodocyclohexane. If the cyclic haloalkane has only one substituent, you don't need to put number 1. So it's just iodocyclohexane. Haloalkanes undergo 2 types of reaction. The first one is elimination, and the second one is substitution reaction. For elimination reaction, haloalkanes react with base in alcohol the condition is heat, and the product will be alkene. For substitution reaction, the nucleophile in the haloalkane will be replaced by another nucleophile. So it's nucleophilic substitution. In nucleophilic substitution, the reactants are haloalkanes and nucleophile. Nucleophile will replace a halogen group in haloalkane, producing this product. Nucleophile replaces a halogen, and the halogen will become the leaving group. A nucleophile replaces a leaving group on an sp3 hybridized carbon. So the carbon that attached to this halogen must be sp3 hybridized carbon. These are the examples of strong and weak nucleophiles. So OH minus, strong nucleophile, OR minus, so this R will be alkyl group, for example CH3, O minus, and Cn minus. If you notice, strong nucleophiles are anions and weak nucleophile is neutral, except for CH3, COO minus. This is a weak nucleophile. Haloalkane can undergo 7 reactions. The first one is reaction with sodium hydroxide. A haloalkane with an alkyl group reacts with nucleophile sodium hydroxide. So the nucleophilic part in sodium hydroxide is hydroxide. The OH minus is the nucleophilic site. So alkyl group is the electrophilic site. OH minus will replace Cl in this reaction, and Cl minus becomes the leaving group, replacing OH minus. For reaction with water, the nucleophile is water, but the product is the same as the reaction with sodium hydroxide. So OH will replace the halogen in the haloalkane. This is alcohol. The product is alcohol when you react haloalkane with nucleophile OH minus, and you react with water, the product is also alcohol. The third one is reaction with alkoxide ion. The nucleophile is alkoxide. For this one, it is methoxide with 1 carbon, C single bond O minus, so it is methoxide. So the product, you're going to have C single bond O single bond C. Halogen will be the leaving group. The fourth one is reaction with excess ammonia. So this must be in excess, NH3. The replacing group NH2 will replace halogen in haloalkane, and the leaving group is Br minus with side product NH4 plus. Reaction with KCN or NaCN. The nucleophile has functional group cyanide or cyanol. So remember that the CN is C triple bond N, not single bond, C triple bond N. So the cyano functional group will replace halogen in haloalkane, and Cl- becomes a leaving group. In reaction with alcohol, the nucleophile is CH3O-. So the product will be alkoxide, C single bond O single bond C. So if it's ethanol, you're going to have C single bond O single bond C and one more C. So if it's propanol, just add one more carbon. So it's like you're removing this hydrogen, and the other parts of it is the nucleophile. Next, reaction with acetate. Acetate is when you have the functional group C double bond O and the C that has double bond O attached to O-. So acetate is a nucleophile in this reaction, replacing halogen in haloalkane, and the product, you're gonna have COC, C single bond O single bond C, with one C double bond O, and the halogen as a leaving group.